Hi, Assalamualaikum. The next subtopic we are going to learn is application of standing waves. Before this, we have learned that standing waves, which is also known as stationary wave, is a type of wave that does not move. So this wave is produced when there are two progressive wave that is traveling towards each other or opposite direction. So apabila ada two progressive wave traveling towards each other, it will form a standing wave. So this application of the standing wave, we can see them in stretched string and air column. So let's look at the first one for the string. So untuk string, kita akan ambil contoh guitar string. Okay, so let's say this is a certain length of the guitar string. Let's say it's 20 cm. So panjang string ni adalah 20 cm. So from here to here is 20 cm. So sama macam dalam gitar, dekat hujung, okay, dekat setiap hujung ni adalah fix. So here will be fixed. Here also will be fixed. So when we pluck the string, apabila kita pluck the string, what happen is this string will vibrate. So this vibration of the string will produce a sound wave. So the sound wave will look something like this. Okay, will look something like this. But because at the end of this is fixed, maksudnya wave ni dia sudah tidak boleh travel lagi. Okay, sebab dia fixed, dia sudah tidak boleh travel macam ni. Disebabkan dia fixed, apa yang berlaku, this wave will reflect. So it will reflect back. Okay, will look something like this. Okay, so this is what we call as standing wave. So dia akan produce standing wave. So let me make this as a dotted line so you can see the difference here. So this is the wave that is being reflected back. So the point where the waves overlap, we call it as nodes. Kita gunakan simbol N. And the point here, di mana mereka tidak overlap, which is at the maximum displacement, adalah anti-node. It is the anti-node. So here kita gunakan simbol A. And we know that one complete cycle here, this is one complete cycle. So from here to here will be equal to the value for the wavelength. Pada sini ke sini adalah satu wavelength. So daripada sini ke sini juga adalah satu wavelength. And then this 20 cm is the length of the string lah here. Okay, so from here kamu boleh nampak lah, the length here will be equal to 2 lambda. So the length here will be equal to 2 lambda. Maksudnya dekat sini lambda adalah sama dengan 10 cm. So the pattern here, we call this pattern as the mood ataupun harmonic. Mood or harmonic. So mood dan harmonic ni akan bergantung kepada dua faktor. First one is the tension in the string. Second one is where the string is plucked. So depends kepada tension. Tension untuk setiap string akan berbeza. Dan juga position di mana string tu akan dipetik. Adakah dia dekat sini or here or here. So depends kepada position tu, kita akan dapatkan different types of moods. Di mana setiap moods ni akan ada its own frequency. So before kita tengok setiap moods di sini, okay, let's look at the wave speed on the string. So the speed of the wave will be equal to the square root of t divided by mu. T here is the tension, mu here is the mass per unit length. Okay, di mana it is equal to mass divided by the length of the string. So Speed macam biasa, unit dia adalah meter per second. Okay, let's look at the different types of mood in string. So, apa yang penting dekat sini untuk kamu tahu adalah the name of the mood. So, what is the name of the mood and how it looks like, the pattern, and what is the wavelength of that pattern, and what is the frequency of that pattern. Okay, tetapi dia senang sahaja because at the end of this, we will use the general equation. Okay, kita akan tengok the pattern for each of the mood. So, the first mood, we call it as first harmonic or fundamental. Nama lain dia adalah fundamental. So, for first harmonic or fundamental, when we pluck the string, this is the pattern. Okay, this is the pattern. So, the wave will look something like this and then they akan reflect. So, the wavelength for the first harmonic ataupun fundamental is equal to 2L, di mana L dekat sini adalah length of the string. So, length tu adalah from here to here. From here to here, this is the length. So, macam mana kita dapatkan 2L ni? Okay, so untuk sound wave, we always refer back to the sine wave. Okay, sine wave adalah macam ni kan, this is the sine wave. Okay, kita tengok semula yang dekat sini. So, this is what we call as sine wave. And then kita tahu untuk one complete cycle, kita akan dapatkan value untuk lambda. So, untuk fundamental tadi, fundamental ni dia punya bentuk adalah satu gelombang saja. This one. So, daripada sini kita nampak dia adalah this pattern only. So, this pattern is actually half of the lambda. So, that's why lambda is equal to 2L. Apabila kita rearrange, so from here to here, tadi tu kan lambda over 2. Lambda over 2 is equal to L. Apabila kita rearrange, lambda adalah sama dengan 2L. Dan frekuensi adalah sama dengan V divided by lambda. Di mana V dekat sini adalah speed of the sound in the air. Dia mesti speed of the sound. Or we can say that frequency for the first harmonic F1 is equal to V divided by 2L. So 1 here is the value for N. So this is the value for N. Okay, untuk yang kedua, second harmonic, or we call it as first overtone. The pattern will look like this and then dia akan reflect semula. So dia akan hasilkan dua gelombang. 1, 2. Okay, dia akan hasilkan dua gelombang. That's why kita letak N sama dengan 2. So, the value for the lambda here is equal to the value for the length. So, sama juga from here to here is equal to the length. And kita tahu satu complete cycle adalah sama dengan lambda. So, from here to here. So, from here to here is the value for the lambda. Okay, sebab dia ada dua gelombang. Berbeza untuk yang tadi, dia ada satu sahaja. That's why dia adalah lambda over 2. Dan F2, frekuensi untuk second harmonic adalah 2 kali ganda the frequency for first harmonic. 2 F1. Okay, for the third harmonic, or we call it as second overtone, the pattern will look like this. Akan hasilkan 3 gelombang. 1, 2, 3. So, N sama dengan 3. Apabila dia reflect, dia akan jadi macam ni. Ataupun senang mau ingat, 1, 2, 3. That's why N sama dengan 3. Sama juga untuk yang ni, 1, 2. So, lambda akan sama dengan 2L over 3. From here to here is the value for L. From here to here is the value for lambda. So, from here to here is half lambda. So, lambda plus lambda over 2 is equal to L, and then you rearrange, we will get 2L over 3. And F3 is equal to 3F1. Untuk setiap ni akan susah untuk kamu ingat value F dekat sini. So, kita come up with general equation, which is Fn is equal to Nv divided by 2L. Okay, di mana V dekat sini adalah the speed of the wave. It's the speed of the wave, not the speed of the sound. Okay, berbeza ya. So, yang dekat sini kita akan gunakan the speed of the sound. For here, we will use the speed of the wave. Dan value n dekat sini adalah value for the harmonic. So, contohnya first harmonic, dia adalah n sama dengan 1. Second harmonic, n sama dengan 2. Third harmonic, n sama dengan 3. Tetapi, ada sesetengah soalan kita akan gunakan nama second overtone. So, kena ingat untuk second overtone, n adalah sama dengan 3. Ataupun kalau kita sudah kira F1 tadi, kita bolehlah dapatkan Fn is equal to n F1. Sama macam di sebelah. Kalau kita mau cari F3, this is the value for n. Here is also the value for n. So, kita akan tengok the example for the string in the next video.